This is Official Nerd Business. Hello nerd boys and girls, and welcome back to our programming series where we take down Euler problems using Python. Let's have a look at today's problem. Today we're looking at problem number 18, which is maximum path sum part 1. As you can see, I've already created the boilerplate file for problem 18, and as you can tell by the name, as it's having a very explicit part 1 in its name, there is a part 2 as well. Let's have a look at the problem by starting at the top of a triangle below and moving to adjacent numbers on the row below. The maximum total from top to bottom is 23, and here is the triangle. I have put parentheses around the numbers they use in their example, but for all the numbers in here, the maximum path from top to bottom is if we take this little zigzag here and include all of these numbers, which leads to this sum resulting in 23. For this triangle below, which I have taken into its own multi-line variable using the triple quotes here, find the maximum total from top to bottom of the triangle below. Note, as there are only 16,000 roots, it is possible to solve this problem by trying every root. However, and here the second problem is referred to, it's exactly the same challenge with a triangle containing 100 rows. So not the 15 we see here, but 100. It cannot be solved by brute force and requires a clever method. Well, we're in luck. Today we're going to look at that specific clever method, which in fact is pretty clever. So let's see, I've set this up with the triangle from the description. You could also put this in a variable triangle down below here for debugging purposes. So you, excuse me, wrong button. You could say, and you could override the triangle variable above here. Don't talk and type at the same time. And you could put the 3 in here and the etc. Also, my code is expecting double-digit numbers. Why that is, we'll see in a second. But you could, for instance, do this: 02, 04, 06, 08, 05, 09, 03, with spaces in between. Yes, thank you. So you could do this for debugging, and your answer should be 23. Then you know your code is doing what you're expecting it to do, and then run it on the big triangle. This variable we use to convert the text we see here in an array of numbers, because at this point all of this is just one blob of text with new lines in it, and we want numerical values out of it in order to be able to add them. And here's the rest of the default boilerplate code, so it can be run on its own, and it can be run from our Euler main py. And usually we would just call attempt number 1. However, there is some code in here that needs to run first if we were ever to make an attempt number 2 here. Like so. Then we still need this bit of code to change the list we get into a list of numbers. And we're not going to do that right now, but for instance, I wasn't sure if we're going to have 1 or 2 attempts on this, but I figured we could do this with 1 attempt. And the attempt itself is very simple. It just calls the traverse function, and the traverse function here will it doesn't even need these parameters at first, but decided to give them along anyway. And the traverse function will solve our problem. So here's a bit of recursive programming. Once again, recursion C-section. We'll get into that in a second. First, how do we treat the list of numbers? First, we want to declare this as a global. So we want to take in whatever is on the module level into this function. Then we're going to split it out on spaces for every row we find in this blob of text. Once we've split that out onto new lines, so this creates a list of lists with per item on the one separate list per row, and per item on that list a string value with 2 digits in it, and then we convert those digits into actual numbers by putting 1 in front of it. So we create 100, and if we take a look at this line, we would create 104, 162, 198, 127, etc. And then we convert those to integers, and then we subtract 100 from it. Why did it use that method? Well, we can't just blindly use the int function on whatever character string is in here, because it would fail at 04, because a prepending 0 is not a valid number for the int function. It doesn't recognize prepended zeros, which is a bit of a shame. But we shake the zeros by adding a 1 to it, by actually concatenating it to 1, making it at least 104 in this case, and then subtracting 100 from it. So now we have each string value from here as a numerical value here, and then we start to run whatever attempt we want. And here it is. So the traverse function, it continuously calls itself until it reaches the lowest level, and then it simply returns whatever item it was called on. And it either returns a certain position from the numerical array here, or when it doesn't, it returns itself added to whatever came out of this function for the 2 cells that are below it. So I'm creating a list here with 2 elements. That's a lot of text for only 2 elements, I agree. But this looks down at the next row at this position. So for each number, so if, for instance, if we were looking at this number, then we want to know what 82 looks like when we add 23 to it and when we add 75 to it. And whatever is highest we want to store here and give it on to the next one, because this 82 gets checked by both 30. When 35 is looking at whatever values are below it, it will see the 4 and it will see the 82. And whenever this 87 is being processed, it will see the 82 here and the 48. So basically we're calling this function on this, which returns itself plus this or plus this, whatever is highest. But when we call it on this, this will return itself plus this or plus this, whatever is highest, and this will return itself plus this or plus this, whichever is highest, etc. So that's how this function travels through this this grid here. It basically, when it reaches this level, it'll do nothing, but when it reaches this level, this is the first interesting level, it'll return 63 upwards plus either 4 or 62, whichever is higher, and in this case you can clearly see 63 plus 62 will be the higher one of both. So this row will assume the values of its maximum lower neighbor plus itself. And same goes for each other number here. And then all of these functions, function calls, because for each and every one of these they get caught up in 2 function calls. So the 71 is in the call for the 70, but it's also in the call for this 11. And it will once again look down and see whatever neighbor is maximum. So that's what this does. It gets both lower neighbors, in which we're interested in, the one directly below and the one below and one to the right. It looks at that value, which is either another function call down below or simply the value itself. It adds itself up to it, and then it gives back whatever of those two values is highest. So that's what this does recursively, and recursion means that to solve a problem you call the very same function again and again until you get the result that you want, and then pass the result back up, which happens here. So let's see if this works. We're gonna start up main.py. Here is main.py. We want to try number 18. 18 does not take any parameters. And the answer is 1074 if we look at this triangle and we trace a path through it. Now I don't know the exact path here, but what I do know is that the highest value that you get starting at 75 here and going down to any one of these numbers, adding everything up in between, is 1074. It took us practically no time whatsoever to get here, and I can guarantee you if you enter this over at Project Euler you will get the green check. That's problem 18. I hope you've enjoyed it, and I hope you've learned something about recursion here today. I hope you check out my GitHub, link in the description, where I keep all of my code for this project, and I hope to see you again soon for problem number 19. Thanks for watching this video on Official Nerd Business. Don't forget to like and subscribe and click the bell icon. Did we discuss everything you wanted to hear, or did we miss anything? Any topics you want to hear in O&B? Leave your thoughts in the comments. See you next time.